Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our fourth graders out there, though all children are welcome to tune in. This lesson is the 10th in our series. My name is Miss Pereira, and I'm a fourth grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website at www.tennessee.gov/education. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons since we'll be talking about things we've learned previously. Today we're going to think about adding and subtracting fraction word problems. A fraction is a number that names equal parts of a whole. We will also think about how to model our thinking about fractions by drawing a model or using a number line. Let's review how to add fractions with like denominators. So let's start by thinking about this question. 4/10 plus 2/10. A model might help us think about this. If we were going to draw a model, how many equal parts do you think we need in our model? Correct, 10, because we have a denominator of 10. So let's draw a model and let's break it into tenths. So I can do 5 columns, 1, 2, 3, 4, 5, and split those in half so that I have 10 equal pieces in my whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. And I'm going to use two different colors to shade to see what the total would be. So my first add-in is 4/10. So 4 of those 1/10 pieces. And my second add-in is 2/10. So 2 of those 1/10 pieces. So all together, how many of those 1/10 pieces do we have? Correct, 6/10. We notice that our denominator didn't change because the size of our pieces didn't change, but the amount of pieces we had did change to 6 pieces. We could also model this on a number line. So instead of drawing a rectangular model, we could draw a number line. Again, we're only looking at one whole, so we can have 0 to 1 on our number line. And how many equal parts do we need to have on our number line? 10, correct, just like we did in the model above. So I'm going to break it up into fifths. 1, 2, 3, 4, 5, and then I'm going to go back and split those in half again to get my tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. Now we can label our tick marks. As we go up on a number line, our numbers get bigger. I should have maybe made this a little bit bigger. My numbers are a little bit squishy. 1 whole or 10/10. So we can start with our first add-in and find that number on the number line, 4/10, mark it with a dot, and then I know we need to add 2 more tenths to it. So we're going to go up 2/10. 1/10, 2/10. So when we add those 2/10, we can see now that we are at 6/10, the same sum that we got with the model above. Great job. So in today's lessons, we'll be adding and subtracting fractions. We are going to use models and number lines that are helpful when adding and subtracting fractions. So let's start by looking at our first word problem. Read along with me. Jessica hikes 2/5 of a mile on a trail before she stops to get a drink of water. After her drink, she hikes another 2/5 of a mile. How far does Jessica hike in all? So I told you that we're going to be adding and subtracting. So today we have to decide, what does it want us to do? So thinking about those two questions, what do we know? What are we trying to figure out? So let's go back, let's reread and figure out what we know. We know that Jessica's out hiking. We know that she hiked 2/5 of a mile on the trail. Then she stopped to get a drink of water. And after that, she hiked another 2/5 of a mile. And what it wants us to figure out is how far did Jessica hike in all? A number line can help us answer this question. So let's pull out our important information and then draw a number line with me. So we know that she hiked first 2/5 of a mile. And then we know she started hiking again the second time and hiked another 2/5 of a mile. So I think number line is a great tool or strategy to use when we're talking about distance, because I can really just picture us walking across that line or up that line. So let's go ahead and draw our number line. We're only dealing with one whole mile, so we can just break our number line up between 0 and 1. How many equal parts do we need to have on our number line? Correct, 5, because our denominator is 5. It tells us how many equal parts are in the whole. So I'm going to break my number line up into fifths. You can do this with me on your paper. I've got 1, 2, 3, 4, 5 equal parts. So now I can go back and label my tick marks, label yours as well. As we go up on our number line, our numbers get bigger until we get to 1 whole mile or 5/5 of a mile. So we're going to start over here at 0, and then we're going to jump up to this 2/5 mark, because when she started, she hadn't walked any, and it told us when she began, she went 2/5 of a mile without stopping. And we're going to mark that 2/5. What do you think we're going to do next? Right, we're going to jump 2/5 again to show the 2/5 that she walked after she stopped to get a drink of water. So 1/5, 2/5. So what do you notice? I noticed that we landed on 4/5. This means that Jessica hiked 4/5 of a mile in all on her hike. How could we write a fraction equation to represent what we modeled on our number line? Correct. 2/5 plus 2/5 is a total of 4/5 mile. Okay, let's look at another problem. Read along with me. Ruth makes one fruit smoothie. She drinks 1/3 of it. What fraction of the fruit smoothie is left? What is this question about? This question is about Ruth making a fruit smoothie. What information do we know? We know that she made one whole fruit smoothie, and then we know that she drank 1/3 of it. So what are we trying to find out? We're trying to find out how much of her smoothie is left. The word problem states that Ruth makes one fruit smoothie. What fraction could we write to represent the whole fruit smoothie? Correct, 3/3. One whole we could write as 3/3. Why did we choose to write it as 3/3? Because she drank 1/3 of it. So she was already thinking about her smoothie split up into 3 equal parts. So if we use thirds for our whole, it'll make our math a little bit easier. So we could model this as well. I'm just going to divide my paper in half here. And we know that she made one whole fruit smoothie So this time I kind of like the idea of drawing that model, her smoothie cup. And we know she was thinking about it in terms of 3 equal pieces, each section representing a third. And we know that her fruit smoothie was full, all 3/3. So she started with 3/3 of a smoothie, or 1 whole, and then she drank some. So some of her smoothie got taken away. She drank 1/3 of it. So if we get rid of 1/3, or we take away 1/3, how much of her smoothie is left? Correct. You can see here that she has 2/3 of her smoothie left. Okay, let's try another one. You all are doing great. Keep up the good work. This time, let's look at Mr. Chang's balloons. Read with me. Mr. Chang has a bunch of balloons. 3/10 of the bunch is red. 2/10 of the bunch is blue. What fraction of the bunch is not red or blue? So let's think about this for just a second. Can you picture Mr. Chang walking out of the store with a bunch of balloons in his hands? And it tells us that 3 of them are red, 2 of them are blue. How many of them are not red or blue? So how many total balloons does Mr. Chang have? How many total balloons is he holding in his hand? Correct, 10. How do you know that? Because the denominator in each fraction tells us 3 out of 10 or 2 out of 10. So we know that he had 10 balloons all together. Great job. So let's draw a picture to help us really visualize what we're doing here. So on your paper, let's pull out that important information. We know that 3/10 of the balloons are red. We know that 2/10 of the balloons are blue. And so how many are not red or blue? We don't really know yet. So let's draw 3 red balloons in his bunch. And let's draw our 2 blue balloons. I know that because of my numerator. How many balloons have we drawn so far? Correct, 5 balloons. So how many more balloons should we draw to make a total of 10 balloons? Yeah, 5 more balloons would make a total of 10 balloons. Oh, that is a bad balloon. So now we have a total of 10 balloons. What fraction of the balloons are not red or blue? Correct. 5 out of the 10. 5 out of 10 are not red or blue. So 5/10 of the balloons weren't red or blue. So what's a fraction equation we could write to represent this? This solution requires two-step addition. The first one, we have to figure out how many are red and blue. So we have to take our 3/10 for our red plus our 2/10 blue to figure out that a total of 5/10 of the balloons are red and blue. Then we have to take our total of balloons, our 10/10, our whole bunch. We have to take away the balloons that are red and blue, and that will leave us with the balloons that are not red or blue. Great job. Let's continue our work. Let's practice a few more adding and subtracting fraction word problems today. Emily eats 1/6 of a bag of carrots. Nick eats 2/6 of the same bag of carrots. What fraction of the bag of carrots do Emily and Nick eat all together? So let's just think about that problem for a minute. What is this question about? The question is about two friends eating a bag of carrots. What information do we know? Well, we know that Emily eats 1/6 of the bag. We also know that Nick eats 2/6 of the bag. So what are we trying to figure out? Very good. We're trying to figure out how much does Emily and Nick eat all together? What fraction of the whole bag do they eat all together? To find the fraction of the bag that Emily and Nick ate together, should we add or subtract? Right, we should add because we're combining the amount of carrots the two friends ate together. Now, let's draw a model to help us think about this question. Let's pull out our important information and please write this along with me. We know that Emily ate 1/6 of the bag of carrots. We know that Nick ate 2/6 of the bag of carrots. Let's draw a model. Let's let this rectangle represent our bag of carrots. How many equal parts do I need to divide my bag of carrots up into? Correct, 6. Because both of these fractions have a denominator of 6, it tells me that they're thinking about this bag of carrots broken up into 6 equal parts. So I can split it into thirds and then split that in half so that I have 6 1/6 sections. And now I'm going to do some shading to model what part of the bag each person ate. So Emily ate 1/6, so we're just going to shade 1/6 spot. Nick ate 2/6, so we need to shade 2 of those 1/6 spots. So what fraction of the bag did they eat all together? Great, 3/6. They ate a total of 3/6 of the bag. What addition equation could we write that would match our model? Great job. 1/6, the amount Emily ate, plus 2/6, the amount Nick ate, gives us a total of 3/6, the amount that they ate together. So what does the solution 3/6 mean in this problem? Right, it means that Emily and Nick ate 3/6 of the bag together. Okay, we have 2 more problems to practice, and I'm going to help you less and less until we get to the last one. Read with me. Lynn buys some cloth. He uses 5/8 of a yard for a school project. He has 2/8 of a yard left. How much cloth does Lynn buy? Remember, let's think through these questions. What do we know? What are we trying to find out? Okay, we know that Lynn went to the store and he bought some cloth. We know that he used 5/8 of it for a yard for a school project. We know that he used 2/8 of it, or he had 2/8 left. So how much did he buy? So what are we going to do here? Are we going to add or subtract? Very good. You're going to add. So I'm going to give you about a minute and a half to draw a model and solve this on your own, and then we can check it together. If you're having a little bit of trouble, think about how many pieces should we divide our whole into? We know that we have a denominator of 8, so our whole piece should be split into 8. Great job. Let's check it together. How much cloth does Lynn buy? Correct. He bought 7/8 of a yard of cloth. So let's look at that one together. We know that he used 5/8 of a yard. And we know that he had left over, he had 2/8 of a yard. So if we take the amount that he used and add it back to the amount that he had left over, we know that in total he bought 7/8 of a yard. So he didn't quite buy a whole yard, did he? He was 1/8 away from buying a whole yard. All right, this last one you're going to do on your own, and then we'll check it together. Carmela cuts a cake into 12 equal-sized pieces. She eats 2/12 of the cake, and her brother eats 3/12 of the cake. What fraction of the cake is left? Now, I'll guide you just a little bit on this one. It's a two-step problem. First, you have to figure out, well, how much did her and her brother eat together? Then, how much of the cake is left? So I'm going to give you 2 minutes to work on this on your own, and then we'll check it. All right. So what fraction of the cake is left? Great job. 7/12 of the cake is left. So let's work through this one really quickly. I told you it was a two-step problem. So first you had to figure out how much did the brother and sister eat together? Well, the sister ate 2/12 plus the brother ate 3/12. So altogether they ate 5/12 of the cake. Then you had to think about how much whole cake was there to start with. We could do one whole, but it's going to be a little bit more difficult to subtract that. So we also know when my numerator and denominator are the same, that represents one whole. So the cake was 12 out of 12 pieces would be the whole thing, minus the 5/12 that the brother and sister ate, leaves us with 7/12 of the cake left. You all have done another amazing job learning with us today. I'm going to post some independent practice problems for you to work on your own. You can take a picture of the screen, pause your screen, and work on these on a blank sheet of paper, or you can go to www.tennessee.gov/education, where you can find this in a printable version to work on at home. Keep up the hard work.